we're going to start working with operations with polynomials. A polynomial, poly means many, nomial means name. It looks like this. If I have 3a squared plus 2a minus 3. What you'll notice here are these three terms. Those are each called terms, all connected by addition or subtraction. Okay? And that's a polynomial. It may be more than 3, it may be less than 3. If you look at one of the terms, 3a squared, that's called a monomial. That's a monomial. A monomial is a number, a variable, or the product of a number and variable. So this product, this is a product, this is a product, those are monomials. A number, a constant, is also a monomial. So a polynomial is a bunch of monomials joined by addition or subtraction. So if it's a single term, it's a monomial. You can have two terms, one term, two term. That is a binomial for 2. This one up here is a trinomial. Trinomial. Because it has 3 terms. If it has more than 3, we don't give it a special name. You just have a polynomial with 4 terms, a polynomial with 10 terms, whatever. Okay? Today we're going to learn how to add and subtract polynomials. So here we have 2 binomials. 5a squared minus 2, 12a squared plus 5, and we have to add them. Basically, you're going to combine like terms. Okay? Now, with like terms, now that we're going to have exponents involved, to be like terms, the variables and the exponents have to match. And when you combine, the exponents don't change. We're going to learn some rules where the exponents do change. But when we're adding or subtracting, they don't. Okay? So we look here, and I see 5a squared plus 12a squared. 5a squared plus 12a squared is 17a squared. Then I see two constants. I see a negative 2 and a plus 5. That's going to give me plus 3. So really, when you're adding polynomials, you're really just combining like terms. These can be as simple or as complicated as you can think. Nothing's off limits here. But let's say I have this. Let's say I've got 2a squared minus 11a minus 4. That's a trinomial because it has 3 terms, and I'm adding it to minus 9a squared minus 2a minus 15. Now, these are in parentheses to show that they're 2 polynomials, but we really don't have to have the parentheses. We could drop them. And again, we're just looking for like terms. I see 2a squared minus 9a squared. 2a squared minus 9a squared is negative 7a squared. Notice my parentheses not my parentheses, my exponents didn't change. I see a negative 11a and a negative 2a. Negative 11a minus 2a is negative 13a. And then I see two constants. Minus 4, minus 15, that is minus 19. Let's look at one more. Let's say I have negative 5x to the 4th plus 2x cubed minus 8x squared minus x. And I'm adding that to x cubed plus 8x squared. minus 3x minus 1. Again, I'm looking for like terms. I have this negative 5x to the fourth. There is no x to the fourth term over here, so I'm just going to copy that. I have a 2x cubed and an x cubed. 2x cubed plus 1x cubed is 3x cubed. I have minus 8x squared plus 8x squared. What happens with minus 8x squared plus 8x squared? That becomes 0, right? Those cancel. Then I have minus x, minus 3x, minus 1 minus 3 is minus 4x. And then I have this lone constant out here, minus 1. So there is what I get when I add those two polynomials. Subtraction is very similar, except for the fact when you subtract a polynomial, that's a minus outside that parenthesis, so you have to distribute that negative 1 first. You have to change the sign of the second polynomial. So this becomes 10n squared minus 9 minus 3n squared, and then I change the negative 8 to a positive 8. So you change the sign of the second polynomial, then you do the same thing. I have 10n squared minus 3n squared. That's 7n squared. I have minus 9 plus 8. That's minus 1. So when I subtracted those two polynomials, that's what I get. Let's say I have, let's look at one that looks a little different. Let's say I have 8x squared y plus 3xy squared, and I'm going to subtract 6x squared y minus 11xy squared. Now here's where what I talked about, like terms, the variables and the exponents have to match. X squared y has to match with x squared y. The variables with their exponents have to match. Xy squared matches with xy squared. Those are my like terms. First of all, though, since I'm subtracting, I have to change the sign of the second polynomial. So I do that. Remember, I'm really distributing that negative 1. I don't have to show that every time, but that's what I'm doing. So now I have 8x squared y. What's like terms with that? The minus 6x squared y. That variable portion has to match exactly. X squared y, x squared y. 8 minus 6 is 2, x squared y. Then I have 3xy squared plus 11xy squared, and I get 14xy squared.